thumbs up. Very good. Very good. All right. Well, good afternoon, everyone. Thank you for coming along and to this encore season of the SensiLab Forum. It's a great pleasure to welcome Simon. I think everyone here has met Simon already. He's just started a new position in SensiLab. He's here for the next 2 months, and we'll be making regular in-person visits, and we'll also be keeping in touch with him when he goes back to the Northern Hemisphere to work in his alternate job at Queen Mary. So I guess Simon has a very distinguished career as a researcher in the area of computational creativity, and he's sort of one of the leading figures in that area, not only as a researcher, but also in someone who really promotes the conference and the research that goes around that conference and the concept of computational creativity. And it's a really great pleasure to welcome him here today. I won't spend hours going through his CV. I think everyone's read the bio that came with the talk. But part of today is also for us to be able to engage more deeply with Simon and his work and to make use of him, should I say, while he's here, and vice versa. So please use today's talk as a sort of opening to ask Simon questions when you see him throughout the lab, and if you need to find out more about what he does, don't hesitate to bother him when he's knee-deep in code. So without any further ado, Simon, thank you so much for the talk, and we really look forward to what you've got to say.
Well, thank you very much. It's really nice to be part of SensiLab. You're very welcome. But I have been this kind of non-entity, just sat at my desk coding for 2 weeks, so this at least gets the chance to see that I do get out and do stuff. The reason I called it yesterday, today and tomorrow is because of the kind of condensed timescale. So I've been in this for a long time, but my position here means that I'm only going to be around in person for October and November, but then I don't just kind of crawl into a box for the rest of the year. I'm available on Skype, and I'll be hopefully interacting with everyone. I will be continue to interact with everyone for the rest of the year. Today I'm going to have a quick overview of computational creativity and creative AI. Then I will illustrate some of the ideas coming out of those fields with projects that I've been heavily involved with, the Painting Fool, the What If Machine, and the Weather app. And then I'll end today with 10 minutes or so about what is really exercising me at the moment, which is creative automated program synthesis, software writing software. And that has an overlap with software engineering and data science, and I'm also keen to talk to people from the faculty in those areas for sure. So a quick overview. So this is a definition that Geraint Wiggins and myself came up with 8 years ago, a working definition of the field of computational creativity. The philosophy, science and engineering of computational systems which, by taking on particular responsibilities, exhibit behaviours that unbiased observers would deem to be creative. So it's a bit of a mouthful, but the main things to see here are particular responsibilities. I made sure that bit got in there because that's kind of an engineering task. How do you hand over creative responsibility to software? And Geraint wanted to make sure this bit got in. Unbiased observers. He's very interested in the science behind evaluating creativity in software. And we know that there's this so-called silicon bias, that if you know that software has made something, then that might well decrease your evaluation of that something. So we have that as a kind of working definition. So we're trying to get software itself to be creative. Still in academia, even with this impact-led agenda, you can still just do things for an intellectual challenge, and computational creativity certainly is that. How do you get nuts and bolts, bits and bytes machines to create beautiful poetry and make people cry or laugh? It's not so easy to imagine doing that. I'm more interested in the idea of autonomous creativity in software at the top there. But this is certainly part of the movement to have creativity support tools to help and inspire people to be creative. And in another sense, it's just the latest tool in the philosopher's toolbox to study human creativity, which we've been doing for millennia. So there's all of these main kind of aims and thrusts to the field. We overlap, of course, with cognitive sciences and philosophy, other computational sciences, and we're part of AI, that's what I think. And we also overlap with cultural domains. And we try and get out there and have some cultural outputs in music, art, design, maths, science, games, poetry, stories. The most recent one there is recipes. Software will generate recipes, people make them into meals, and the best you can say really is that nobody dies when they eat them. But they're getting there, and IBM, of course, have got into recipe generation in a big way. And we try and put on art exhibitions, we try and get scientific publications from computer-generated works, music concerts, anthologies of poems, that kind of thing. And we try and get involved with industry. We should do more of this, but video games companies are particularly interested. Art galleries, advertising companies are keen on this as well. Yeah, we're interested in working with all range of people from the creative industries and further afield. In practical terms, we build and we experiment with software which performs artifact generation. It makes stuff, whether it's a poem, painting, game, mathematical theorem, fictional idea, story, a sonata, or a recipe. Then we apply these software systems to practical creative projects, ranging from where the software is just a muse, it just gives you inspiration, all the way through creativity support tools to autonomously creative agents. We are interested in what progress means in computational creativity research. As you'll see later, I don't believe we should be defining what creativity is, so we can't say progress towards software itself being creative easily, but we can define what progress is, and we have formalisms for that in the field, and I've contributed a bit to that. We raise philosophical issues in the broader creativity studies through the through the study of software process and product, and that's relative to all these other fields like psychology and cognitive science. A big thing that I do in particular and others is to manage the perception of with the general public of what it means for software to be creative through art exhibitions, poetry, slams, game jams, demonstrations and talks, that kind of thing. So we get out there and we try and get feedback not just from the general public about our own projects, but about the general question of what it means for software itself to be creative. My impression is that there are three main areas of challenge for the field. In technological advances, we need to get computational ideation going, software to invent ideas. That's not the same as generating text that people can interpret as ideas. Twitter bots do that all the time, it's very easy. But the software itself having an idea and knowing the ramifications of that and the preconditions and so on, that's a different matter. So that's a big problem for the field, let's say an opportunity for the field. And that is very heavily enmeshed with meaning generation. Software doesn't tend to know what it's saying and what the meaning of the words that it's creating are. Complex artifact generation, this is why I got into video game design. Video games in many respects are a killer app for computational creativity. You have to generate music, you have to generate sound effects, rules, characterizations, visuals, you have to generate all sorts of complex artifacts in order to get a video game going. And automatic programming is the thing I'm going to be talking about today. Writing software, I think, is a big challenge for us. In terms of scientific assessment of progress, we tend to have been quite naive in saying, well, if it produces good output, then it must be creative. But that just isn't the case. You can write a 10-line piece of software to generate a nice image, but you would never call that 10-line bit of software creative. So we need to move from looking at what software produces to looking at how it does that. And we need to embrace this notion that creativity and art and so forth are subjective, and embrace the fact that there is no definition of creativity which we can appeal to. And we need to get past some challenges in sociological acceptance. We need to address the fact that software isn't human, and despite what the singularity theorists say, it's not going to be anytime soon, and we're not going to become a computer either. And we need to work out what the appropriate uses of creative software are. There are ways in which we can really annoy people in the creative industries and ways in which we can support them. And I think a big thing on the horizon, which I don't cover at all today, is authenticity. How can software use its own authentic life experiences in the creative act? And that's one for a few beers one night. Creative AI is this new and emerging field where people in machine learning and specifically in deep learning approaches and other AI areas, they've been using AI techniques to generate stuff recently. And they're normally through things like autoencoders or generative adversarial networks. I call it a hashtag creative AI because it's not really a field, it's a community on Twitter with this hashtag. And the creative AI movement is specifically not to produce creative AI, so it's a bit of a misnomer, but rather to enable people to be creative with AI technologies. And in my disingenuous way of looking at this, it's really to help already creative people to be more creative, I think. But they're really more interested in mass rollout to commercial level of AI techniques for creative purposes. And a great example of this is Prisma, the iPhone and Android app, which does image filtering using neural networks. It's really very good at doing that. And they're really interested in the highest quality of results possible, not really about the process or whether software is creative or not. And actually many people in the field really take offense at the idea that software itself could be creative. It's really just there to help people to be creative. So here is a good example from Creative AI. I'm sure all of you, if not, if most of you have not seen this. Does anyone actually recognize these people? Some of you get the gag already, I presume. Well, that question means nothing. These aren't people. These are computer-generated images, 2,000 by 2,000 pixels, from a neural network trained by NVIDIA on 30,000 high-res and highly touched-up pictures of celebrities, models, and actors. So it's weird to think that these people don't exist. It really does change our perception. I mean, this guy, he might be smiling, but he's clearly going through his third divorce. But he's not, because that's not a person. It's just a bunch of pixels. It's weird. So that was my outstanding AI moment of the year. And NVIDIA did a really good job of advertising. This is entirely for advertising purpose for NVIDIA. And they're pioneering advertising through scientific publication. Again, another thing I can cover in detail later on. Here's another fantastic, technically fantastic project. John knows all about this one. These guys, this is a €1 million project in the Netherlands. Some incredibly good machine learning people scanned in lots of Rembrandt paintings and automatically generated using machine learning a new face. So this isn't a real Rembrandt painting. This wasn't even the subject of a Rembrandt. This is a generated face like the NVIDIA one. They also teamed up with some makers in a maker lab and did amazingly detailed 3D printing based on the paint strokes that Rembrandt used. And beautifully kind of really tiny impasto painting of this. And this was done by for ING, the bank, and by an advertising agency, and it won all the prizes. And the fact that I'm still talking about this 2 years later shows you how amazing this project was in terms of advertising. And at the time of writing, this is a long time ago, 1,400 articles had already been written about this particular project. This is one of those articles by Jonathan Jones, the art critic for The Guardian. He says, "What a horrible, tasteless, insensitive and soulless travesty of all that is creative in human nature. What a vile product of our strange times when the best brains dedicate themselves to the stupidest challenges, when technology is used for things it should never be used for, and everybody feels obliged to applaud at the heartless results because we so revere everything digital." One of my favourite quotes of all time. Now, of course, Jonathan Jones is paid to be acerbic. He's paid to be divisive. He's an art critic. But this is just the kind of far end of the spectrum of upset that this caused. So this is a very amazing technical project, very badly handled in terms of culture, except, of course, it was advertising. So this kind of thing is amazing for advertising purposes. But this is the kind of bridge that I worry about the new creative AI movement burning to the art world, which people like John and I have helped to build over the last 20 years. What I don't think that people in creative AI and lots of people in computational creativity don't really get, that art is primarily about humanity. It's a celebration of our humanity. It's a celebration of our community, our ingenuity, creativity, and productivity. And process and personality are far more important than product. Despite movements like Death of the Author, where the philosophers there say, don't think about the author of a work of fiction or a novel, think about what the words say and contemplate the art in its own right. I'm afraid that doesn't translate into the computational era where software can make art and text and poems. And the other thing I want to point out philosophically is, so if you want to get into an argument, ask me what is creativity. That's because the word creativity, I believe, is essentially contested. And basically we've chosen to disagree about what creativity means as a driving force for society. I want to point this out a bit further by reading out that this is an extract from a paper we wrote. Galli introduced essentially contested concepts as those for which their proper use inevitably involves endless disputes about their proper uses on the part of their users. To which Gray added that disputes cannot be settled by empirical evidence, linguistic usage, or the canons of logic alone, and Smith noted that all argue that the concept is being used inappropriately by others. So basically, if we're not arguing about creativity, then we're not talking about creativity. We're not meant to have a definition of creativity. I'm not meant to be able to point out that you're really creative and you're not, or you are, you're 20% creative. That isn't the notion, that isn't one of the meanings of the term creative. We're not meant to be able to do that. So as a scientist, that's scary as hell, because we've got it's a movable feast, and it's a moving target. We've got no reference point to work towards, but it really is the kind of reality of the usage of that term. So we're not going to get this, sadly. Again, I'm happy to argue that with you, in which case we'll be talking about creativity. But if you think you've got a definition of creativity, I bet you don't. So now moving on to these illustrative projects, really very practical. I am very much a maker. I'm here in a maker lab, but all I've done is type into a keyboard. So I want to show you some of the things that I've made with these projects, or helped to make. So a big project, 18 years of work roughly, is a painting full. And the aim here is for the software itself to be taken seriously as a creative artist in its own right one day. This involves graphics, natural language processing, AI, machine vision, lots of other stuff. And I see painting very much as 99% a cognitive act and 1% putting marks on the canvas. Graphics tend to see it the other way around, 99% all about the image and putting marks on the canvas, and 1% about the AI. So the goals of the project are to implement into the software behaviors onto which we can genuinely project words like skill, appreciation, imagination, learning, reflection, intentionality, ideation, and innovation. These are the words I think need to be there. It's not a kind of golden bullet. If they have all of that, it will be creative. But if it doesn't have some of these, it's very easy to say it's not creative. I want to use this software to engage the general public and specialists from the art world on thorny issues surrounding computational creativity, and maybe change people's minds a little bit about what it means for software to be creative autonomously. And personally, to understand the value of humanity in the arts and the art world in general. Here's an example, early doors. This is maybe 10, 12 years ago. This is the science editor for the Daily Mirror. Came to interview us about this project. We won a prize for it. And he is expressing one of 6 emotions. In this case, it's disgust. The painting fool has extracted the apex image where he's expressing it the most. It's found where his eyes, nose, and mouth are in order to be able to pick out a likeness. And it's recognised the expression of disgust. So it's chosen a painting style like Monk's The Screen to kind of express that a little bit more, to bring it to the fore. And sometimes it uses greens, which is quite a disgusting look for a face, to emphasise his disgust. So that's a little bit of appreciation of the subject matter and how it can try and enhance the expression being shown. So a little bit of appreciation there. Here's some more portraits. We've got anger, disgust, fear, happiness, surprise, and my favourite here was sadness. This was my Facebook profile picture for many years. I really was that miserable. It was the middle of the night and I had to get to Cambridge. It was a bad night, but the software picked that up and produced this painting, which is in pastels, simulated pastels, which I quite like. It's generative, so in terms of the imaginative aspects of the software, it can paint things which don't exist in reality. This is obviously a constructed scene. This is a Presidents series. Can anyone see why I called it the Presidents?
Because they're trees.
They're trees, like the Ents, and they have faces.
And they're presidents.
And they're presidents, why? Well, we have a ringer at the back there, very good.
I haven't seen it before.
You haven't seen it before, okay.
I promise.
It's amazing. Some people can barely see faces. Other people cannot see anything but faces. It is indeed, that's Obama. Can you see Obama in there? Peace for hope, for change, for hope, for peace. And these are really quite broad brushstrokes we're using here, but still managed to pick out a likeness, albeit quite sketchy. That was generated using constraint satisfaction solvers, old style AI, no machine learning, no neural networks at all in the making of this, with all sorts of things in there to place items on the scene. More imaginative stuff, of course, this abstract kind of pretty art doesn't really exist, using a particular approach to that. I got the painting fall into 3D scene generation, so it can place virtual chairs into virtual rooms, organize the lighting to get a good spectrum, organize the camera position to pick up that spectrum, and then take a photograph virtually, and then use a photograph to paint pictures. The series for this was called Technicolor Dream Chairs, which was a very bad name, and I expected very colourful things. So when I woke up and saw this in the output, I was genuinely surprised. One of those very nice moments in computational creativity when you think, wow, I didn't expect that. It just so happens that one of the colour palettes that the painting pool was able to use was just grayscale, and this particular style really emphasises a kind of melancholy look to this chair, it's a bit like lace. Really had no idea that was going to be produced by the software, but has been a big part of my life since actually that chair's become a little bit famous. Here's another one. You can see the lighting being arranged there, yeah, it looks like a real photograph was used to paint this virtual picture. People kept saying, why are you generating things which people can generate? Can't you be a bit more, avant-garde? And so I started looking at multimedia things, So this is just a video of the painting fool painting. And if you look on my desk at the moment, the painting fool is painting pictures just like this. This is called the dancing salesman problem. It's painted all in one long stroke, albeit the changes of colours change. But of course that's very similar to the travelling salesman problem, a bit of computing in-joke there. And it goes on and on until the whole thing is produced. And because it's a terrible algorithm that I implemented for the travelling salesman problem, you get these long strokes where it makes corrections. That's the next city along. And that really adds to the dynamism. I'm very pleased with the results here. I got it to produce some virtual sculptures. This one is called Uneasy. Days of horrible projected geometry to get this to work. You can only view the picture from two angles, the front and the back. This is a sculpture which couldn't exist in reality, it's too complex, but can exist on the computer screen. Again, this is doing something that people would have a hard time doing themselves. It's a bit difficult to animate that, but the software could do it. Paint dancers. I wanted to ask myself, is it possible to paint 32 portraits of people at dog store? This is when we were there, back there, John. Paint 32 people with the same paint strokes. This is basically rearranging the paint strokes to pick out all these different people. That's Geraint Wiggins, if anyone knows him. In the longer version, you're in there, John. All 32 are painted up in this kind of very art brut kind of a way. Fauvism, I should say. I do know a little bit of art history. Very like Fauvist colours, at least. So that's paint dancers, and I got the software to actually generate 3D plans of galleries, put real virtual chairs in there, and paintings of real virtual chairs in the real virtual gallery. It gets very complicated. And then organise with a bit of A-Sturch planning a route around, and it can put some sculptures in there as well. This one's of a hand, so it can, and then guides you around to give you a bit of a more of a feeling of presence, I guess. So that's gallery design. So this is one of the more advanced projects with the painting fool to test out the question of intentionality. So when you sit down for a portrait, it's reading the newspaper, The Guardian, and that's putting it into one of 6 moods, from incredibly happy to very miserable. And that mood affects everything that it tries to achieve from there on in. And it tells you the kind of mood it's in and what it wants to achieve. And it's quite clear that it's using you as an art material. It doesn't say, how would you like your portrait, sir? It says, thank you for being my model. Then it organises you in order to try and capture this mood, which is a bit crazy in this one. Then it's choosing an adjective which will express that mood, and that adjective is tied to a neural network which is going to be using machine vision to check whether it's done what it wants or it's achieved what it wants to achieve. So it's finished now. There's a bit of smoke and mirrors as it takes my head out of the background. I don't normally have the luxury of a green screen. Normally it's just using face detection. This is a bit of a diversionary technique to keep you occupied while it's doing some processing. Into the background it's putting a piece of evolutionary art, kind of abstract, fractally like art, which has also been chosen to reflect the adjective which reflects the mood. It's applying an image filter to the foreground and the background, which has also been chosen to reflect the adjective which reflects the mood. And then it's choosing a painting style which has been, it's found over the years, has been good at achieving those adjectives. And then it turns those images into segmentations and appears on screen and starts painting, just on time. This is about twice the speed as it normally goes on my desktop machine, so I'll speed it up for the video. Sadly we can't watch it all. I'll have to fast forward. The music's great for this actually. So about here it's mostly working on the background, and about now it starts putting in some details of the foreground, which of course is my head. My face, and then I'll leave it for a second. Then it will finish the piece off. It's done some edge detection, so it can actually put in the outlines of my eyes, nose, and face, and so on. So once it's done this, it's now evaluating, using these neural networks, whether it's achieved something that it wants to achieve, which is the mood it wants to project. So I'll fast forward a bit. It says thank you for being my model, and it's now producing a commentary all about what it was doing, why it was doing it, and what it thinks of what it's achieved. And it prints it out. Normally I have a printer with me. I do a lot of public engagement with this. And this is the kind of printout that you get. It tells you that it was in an experimental mood. He wanted to produce a glazed portrait. This is a mind's eye conception, a very quick image filtered version that it wants to achieve, but it has to use this crazy method of simulated paints and a paintbrush. So that's what it wanted to achieve, a kind of a glazed looking portrait. And this is what it's produced, as we saw. And then it critiques, has it got more or less glazed using this machine vision technique? It thinks it's quite glazed, but the style has lowered the level from the top to the bottom. So it's a bit annoyed about that. So that's it, the whole process really. The last thing which isn't visible is that it's using a little bit of machine learning to update the probability distribution so that it's less likely to use this painting style in the future because it feels it's failed to get across the nature of the adjective being glazed. So the question there is, was it intentional? Did the software intend to do something? Did it intend to express glaze? I certainly didn't have much control over that particular artistic process. I was just sat there being the model. And I challenge people to say why they think it might be appropriate to use the word intentionality on the software there, or why they think it's not appropriate to use the word intentionality. There's no right or wrong answer, but I use this to kind of test the water with academics and researchers alike, as well as the general public and art people, people from the art world. So, I put on exhibitions. Here's one. This is 300 pieces of, you can just about see it here, 300 pieces of photographic paper, all stuck onto a 3 meter by 1 meter piece that we exhibited in Paris, and in a kind of crazy photo montage. And it's called No Photos Were Harmed, because even though it's on photo paper, these are not from figures of real people. These are generated figures using a context-free design grammar, CPG, some nice software I managed to get hold of. And this is clearly not abstract art in the sense of having no meaning. It's figurative, but it's certainly not like Photoshop in terms of starting with a photo and ending with a kind of painterly rendition of it. That was part of a bigger festival where we had computational recipe generation being turned into hot pot. We had poetry reading, we had an exhibition, of course, and the painting forward was painting its portraits during that time. And there was live music here. Where the software's simulated emotions were being fed into the musician's work desk. Stefan, I almost forgot his name. We also go out there and we do exhibitions, summer demonstrations of this. This is 3 days and one very scary evening where there was alcohol and no children at the Science Museum, and the adults were just getting more and more drunk and leery, I guess the phrase would be. But it's very, very popular. We had hundreds of people have their portrait done, mostly children. And the Guardian journalist, this guy came along. He brought with him semi-famous watercolorist. He's an amazing artist. And she had plenty of time with him. She could also take it up to a studio. My software had 3 minutes to generate its portrait. And then the Guardian writer wrote this up in the Guardian, and basically it was a hatchet job. This software's no good. It's no good for anything. He basically found 5 or 6 bits of creative software and showed that they're all really bad at it compared to the world's best humans, which wasn't surprising. What was surprising is how kind of vitriolic the hatchet job was, but we kind of knew it was coming. The painting floor was painted 3 or 4 famous people. This is Habu-san, the world Japanese chess champion, who was doing a documentary on AI, and he came to London to interview us there. This is me being interviewed by Dara O'Brien, who was on Australian TV just last night. And while I was being interviewed while the painting floor was painting his portrait in the background, made him look like a walrus, which really didn't go down very well, but I don't think it really mattered that much. That is the worst portrait I've ever seen the software do, to be perfectly honest. But it was live, and I didn't fix it to cheat. I think the audience appreciated that. This is the New Scientist live event. This is an interesting moment when Mrs. Yang Lang came to visit us in Falmouth. So she is very famous. She's the Chinese Oprah Winfrey, 33 million social media followers. If you're Chinese, you know all about her. She's very well known. She rocked up in Falmouth to interview me for a 10-part series. I was only in a couple of parts. And she took a liking to this piece and bought it from me and gave me £500 in ready notes, cold hard cash, straight from a wallet. I have no idea how much there was in there. It's dangerous to walk around that kind of money. The reason I like to do these kind of things, so then she went round and talked about this experience, and it made it into the AI documentary. And I asked one of the production assistants what the likely viewing figures were for this AI documentary, and the assistant said, with all honesty, we're hoping for 1.2 billion. 1.2 billion people have seen this 10-part documentary, possibly. So many hundreds of millions at least, which kind of blows away any more public engagement I should bother doing. But really the interesting thing for this was that she took this painting to this Chinese artist. It's quite a well-known artist over there, and asked him to comment on it. And this kind of feedback is really great. So he said, basically, he's pointing out that the personality is missing. There's no process. He's no idea what the software has done to produce this picture. If it was by a person, he'd have a completely different commentary on it. And he's trying to point out that there are 3 differences about the age, the relation to the age, and about the expression that are missing here, really. And saying that human beings can define themselves by their weaknesses and defects, but machines tend not to do that, which is a really nice insight. And I've kind of analysed this, I had it translated, and it's very useful feedback from this kind of expert. But not surprising, because he only got the output, and Mr. Jiang Lang didn't explain to him what the software did. And really, we need to get across more about the process. So that was the painting full, and there's lots more to talk about on that topic if you're interested. Another project I've been heavily involved with, I led this project from Goldsmith, was the What If machine. This was an EU project with Joseph Stephen Institute, Dublin, Madrid, Cambridge, and ourselves at Goldsmith. And it was an antidote to this horrible obsession that AI has with the truth. Everything has to be about the truth in AI. It has to be a theorem which is actually true, or a machine learned rule which is actually true about your data, or a constraint satisfaction problem being properly, truthfully fitted. But large parts of culture are fictional. Peter Pan didn't exist. There are no witches and wizards in Hogwarts, sadly. So AI just tends not to bother with the fictional side of human culture. And so we wanted to write this software to produce fictional ideas which were strictly fictional, which was a really big problem actually. It's easy to come up with things which might be fictional, but you don't know whether they're actually true or false. And basically it was just generation of text which could be interpreted as ideas, expressing a world which doesn't exist. And that was meant to be a general technique for computational creativity to inspire short stories, poems, cartoons, games, by people and other software. We had as a nice target one, a what if by Douglas Adams, a famous author, which is what if birds aren't singing but are already screaming because they're afraid of heights. It's a lovely, what if, and you can imagine, and there has been an episode of the Futurama with that in, I think. And the software works, I don't have time to go into it, but taking facts from a database of facts called ConceptNet, and inverting and subverting those facts with more and more layers of natural language processing in order to produce the ideas. This didn't go down well with this gentleman, Paul Nuttall. He was, for a brief, glorious period, head of UKIP, the anti-EU political group in the UK, and he said that the EU must be joking spending all this money on this What If machine project. We use that as a badge of honour. I mean, really very happy. If you're not pissing off right-wing, ultra-conservatives like this guy, then you're not doing great science. So I was really very pleased, and we were very happy with this. So there isn't time to go into it, but we have a flowcharting system called Flower. It's available online, and it starts with ConceptNet, and basically everything comes out of there using all sorts of grammatical and linguistic techniques in order to check whether something is making sense. So lots of the what ifs coming out do sound like they are completely randomly generated, because this isn't perfect yet, but you know there is intelligence behind it, and many of them are actually very interesting and could be valuable. We then take the output. This is our part at Goldsmith. The output then goes through narrative generation at Madrid. This is all kind of server linked. The narrative generation produces narratives and numbers which describe the narratives that are possible from these what ifs. Those numbers are then fed through a machine learning system at JSI, which has been trained using hand tagging from crowdsourcing to try and evaluate which of the what ifs are going to be the best. And there's lots of papers about this if you want to learn more about that. Here are some nice examples. What if a fish got drunk? Quite a nice, concise one there. We wanted to do little kind of Disney characterizations, very easy, low-hanging fruit. What if there was a dog who was afraid of bones? What if there was a little cat who was afraid of milk? Then we got onto the more kind of Kafkaesque storylines. What if there was a lawyer who woke up in and Ali as a cat, but could still use a telephone. What if? This is my favourite for a while. These are two of my favourites. What if there was an old dog who couldn't run anymore, which he used to do for fun, so instead learned how to ride a horse? And you can imagine a knackered old dog in a video game trying to get on the back of a horse. That'd be pretty cool. And you can see that they're turning into kind of mini narratives now, not just ideas. This was great. What if there was a poor boy who was born with a horn, which made him great at communication, and he went on to become a famous slave? So there's a bit of Gabriel Garcia Marquez magical realism in here, a poor boy born with a horn, and a nice twist, born poor, but becomes a famous slave. Really, you can imagine a story being written about that. And there's a picture, of course. So a dog and a horse isn't fictional. There's loads of dogs and horses. And they go over jumps and everything. So we had a hard time knowing whether something was actually fictional. And of course, a lawyer on the right there. We have a little book, if you want to buy it on the Kindle. It's really kind of a sketchbook. There's loads of spare pages in there. If you just take some of these ideas and draw pictures, it's aimed at children, I guess. But the paperback is reasonably priced in dollars. And there's loads of what-ifs there which were handpicked by the team to illustrate how cool some of these what-ifs were coming out. The big cultural success of this was a musical theatre piece called Beyond the Fence. So Wingspan Productions, on behalf of Sky Arts, contacted us and said, we want to make a computer-generated musical. And I said, you're crazy. That's way beyond the possibility. But Kat Gale, who organised this, she is a kind of force of nature. And a year and a half later, this was the output. And the whole time I was saying, I really want the What If machine to come up with the original concept for the show. And basically, I kept on with that. Teresa, the lead RA for us, spent 3 months developing a version of the What If machine which was useful for musical theatre, and then we gave about 10 really good ones to the two writers, and they chose what if there was a wounded soldier who had to learn to understand a child in order to find true love. So the original concept there came from our software. Their genius was to turn it into a show about the Greenham Common women's movement. This was an anti-nuclear protest. And the women on Greenham Common were there with their families for like 17 years, some of them. And so they made it about a little girl who is mute. She's on the wrong side of the fence to the GI from America. Through his interaction with the little girl, gets to know the mother, one of these characters, falls in love with the mother. There's a mother. Falls in love with the mother. They run off together. There's lots of singing and dancing. It's a musical, so it's not meant to be, thought-provoking. And they called it Beyond the Fence. It was a lovely moment. And to our knowledge, this first time that a piece of software has been credited with the original concept on the playbill. So we got some great, some brownie points from the European Commission for that outreach. Oh yeah, some pictures here. We did Meet the Scientists on the stage, and there's a paper all about that process. There was loads and loads of people. Lots of the narrative, lots of the music was generated by software, not ours. Lots of the dialogue was generated by a neural network, which was excruciatingly bad. And the two writers, who were these two guys, were basically saying that lots of software was very difficult to work with, but they really, really liked the What If machine. They thought it was a very useful bit of software for the creative industry. So of course, we dined out on that and told the European Commission reviewers all about it. Right, so I have a demo of the third piece of software from our work. This is where it all goes horribly wrong, or not. So Weather is an iPhone, iOS, iPad app. Thanks. And we're coming from many angles with it, but I'm going to start with the democratization of game design angle. How are we doing?
Is it unlocked?
Yep.
5 times.
We've tried this, many times. Have I done something wrong? Ah. Turn it off and turn it on again. That'll be fine. Oh, that worked. Okay, I guess I'll have to skip this. We tried this many times.
We did.
Yeah.
I swear.
Well, there we go. Okay, there is sound. Could you turn the sound
Yeah.
up a bit? I think
Yeah.
something. It's the only thing I have in presentation with flat sound. So we call these fluidic games. So these are games which are not meant to be fixed in space and time. You're meant to be able to alter them, send them to your friends, send them around. Very much part of the social media generation. There are 4 packs of games. I've demoed this to a number of you in the lab already, so I won't spend too long on it. And they're very simple, very casual games. So you get points here for heading the ball with your alien character. And the beauty of this app is that if there's anything, lost the line. If there's anything you don't like about the game, let's say we don't like the alien, and we really want Bunny. Different game now because you can keep the ball inside the ears. So really the physics changes, the game changes. Sorry, I shouldn't, yeah. So everything is available for you to change the games, or you could just make, you could just make a brand new one from scratch. Show you a few other ones. This one's a beautiful game. You just have to tap the bees who are getting in the way and avoid tapping the flowers, because you lose a life if you tap the flower. Another one I quite like is Falling Star. So you have to just move around to capture the stars here. Quite a different game, a lot more dynamic. Shows you the kind of range of the games. 2 more games to show you. One is, this is my absolute favourite, Monkey Splat. If anyone can beat 460 points on this, then they will have the world record. Not that the whole world wants to play this, but that's a great game. It's my favourite. And there are some more Zen-like games. So this one, you get a point every time the balloon gets to the top of the screen. Okay, which is not at all easy, but when you get it there, it's a Zen-like feeling. Let's alter this one, let's say. The design screen enables you to change the characters and how many there are and how big they are. How you interact with those characters, you can tap them to explode, spring, bounce, ping off, and there's always scores associated with everything you do. In this case, they're both off. You can change some of the physics. You can make the balloons a lot faster. This will make the game far too difficult. I'm not worried. Yeah, far too difficult. And you can even change how random it is, in which case it'll go all over the place. You can change what happens when things collide, whether they bounce or whether they explode or whether they cluster together. Again, with scores for this. That's that screen and that screen. I spent a long time getting the audio engine working. So there are 6 soundtracks, which we commissioned for this. And you can turn up and down the volumes for each, but you can also change the tempos. So you get a very different sound there. Or you can choose to have ambience, which means you've got all sorts of noises available to you. Thunder. Let's have a guitar. That's because the volumes are down. Let's turn those both down. So you can get you a nice effect. Weather is for outdoorsy kinds of games. The last few screens are, you can change where the background is, what time of day it is. You can change how you control the central character. There's various different methods there, from teleporting to kind of swipe-based dragging. And the final screen is your win and lose and scoring in live conditions to make it into actual games. If you turn all of those off, it becomes an art piece, basically. So, the only bit of AI in here is... hang on, I need to go back to the games pack. You can download a game, you can send these around by Twitter. They fit into 140 characters. You can start from this clean slate, or you can get inspiration for your game. This basically does an evolutionary mashup of the existing games and gives you what we would call a fixer-upper. You can change the name. And you play the game and you have to work out what's going on. Oh, I got the point. If you read the screen, and you get used to reading these screens, you know what's going on, how to win and so forth. And that might actually be a decent game. 2 or 3 times out of 10 it'll be a good game, you can enjoy playing it. The rest of the time it's what I call a fixer-up, and you need to alter it, and you've got everything available to do that. So I need to move on. So that's Weber. Please do ask me about them. I have a few slides about that. Now, this one goes back in here. And what have I got
at the end of that?
That's it. Go back on. There we go.
Yeah, usually.
Do the slideshow. Thanks. So I'm running out of time, but not got through everything. So we've done lots of game jams, lots of after-school clubs. Kids love this. We think it empowers them to make games, not just kind of problem-solving, mathsy kids, but also ones interested in art and design. And we've had lots of fun with the kids on that. Lots of papers to come out of this platform: AI, HCI, art, and game design. Please ask me about those. And we set up a company to try and make this into the next Google. Founded last year, closed this year, folded. So another success story in my life. Now I've put this up here specifically to try and attract Dilpreet's attention, because I think this is the coolest thing imaginable. This is a mock-up of, it's a fluidic game just like Weather, so you alter the game. All of this is designed on screen. And it's a shoot 'em up, so you've got all sorts of things available. I've written all this code. It's absolutely my code to play around with. And what I want to do is be able to take a photograph of some texture like a piece of wood, and then say, make my game look like a piece of wood, or made out of wood. And it applies style transfer from machine learning to all of the assets in the game, and makes it look like wood, which is it's a fantastic look. And really, if that's on a server somewhere, I think this would be an amazing addition. And you can have levels where everything's on fire or underwater. Really adds a lot. Style transfer, I don't think, has got huge amounts of legs in terms of artistic benefit, but in terms of content generation, I think it's great. And you can, yeah, you can get all sorts of other game styles out. Like this one is on fire. And this one is like a particular artist that I like. I saw a picture in the newspaper, found an example, put it through style transfer, and it looks a bit like that artist has made this game. So we wanted to turn this into a brand new social network where people share games. The world needs more social networks, of course. People share games as fluidly and easily as they share text and photographs and videos. And when you can do that on Twitter or Instagram, then I will be the most bitter man in history, because someone will have made a lot of money out of my idea, our idea. So there's still all the code available for that, and I think this is going to be the coolest thing to resurrect that. I've also been using some of these new creative AI tools for building generation. This is trained on building facades, and all you have to do is generate a scheme. The painting full generates this facade schema, and then the software turns it into reality. This is old style, context-free design grammars for the trees, and you can turn that into pieces of art that the painting full has painted up. And I even made a game out of this called Space Hopping Tree Hugger in Hanoi, where you have to jump your way to the top of these towers of Hanoi. How you can get the terrible pun there. So I think I lead a life about, no, there we go. So that's what you can do with kind of creative AI meets computational creativity. So what I want to try and attract your attention with is what's going to occupy my time for the next 10 years or so, if not the rest of my life, which is creative automated program synthesis. So this was an interview in the New Scientist 4 years ago, and I put this up here to remind myself that I've not actually fulfilled any of the promises I said to the interviewers there. I think computational creativity is going to be massively enhanced by software writing software. So it solves as many philosophical questions as it throws up creative affordances, and it will be. It's partly the reason why I've stepped down from all of my management responsibilities, and gone back to being essentially equivalent of a postdoc, which is great. If you look at what's available in automatic code generation, machine learning is obviously code generation, but it turns into a kind of gigantic black box neural network, no good for understanding particularly. But there are exceptions. Inductive logic programming produces logic programs, and they can be understood. Genetic programming is fantastic. It works really, really well. But it's not necessarily the best way of making code is to do crossover and mutation. John and I are arguing a bit about this, but I think that it's limited. I don't think people program like genetic programming systems program. And then there's this whole area of automated program synthesis. Microsoft Research are very involved in this. You can use proof of program techniques. That's what John Whittle did for his PhD work. Automatic code generation as a theorem proof. And more recently, deep learning has been used over snippets of code to generate more code in the same kind of style. And the problem here is that the researchers are completely stuck in this idea that you have to solve a problem with this technique. You're given a program specification like input and output pairs. Here's some inputs and outputs. What is a program which takes the inputs and turns them into an output? That's really not a very creative approach. Whenever I meet people with software which can write software, I say, wow, what do you do with it? I'd be like a kid in a sweet shop. Tell me all of these amazing things you've done with your software which can make more software. And they always go, well, we've output a few problem solutions to these problems. And really, they're not taking advantage. So the question is, what would you do if you had a code generation system? And I'm going to start at the beginning really with this and start with basic machine learning. This is one of the things you can do with a creative code generation system. And this is a pop quiz here. Can anyone tell me why the 3 rows are yes, 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 and the others no, no, no? These are not. This one's an easy one, but the rest get a bit harder. If you look at columns, I'll give you the answer. I need to refresh myself. Column 2, or V2 is 12, and V4 is 11. 12, 11, 12, 11, 12, 11. No others have got it like that. That's classic machine learning. A decision tree could do that kind of thing. So that is the kind of answer to why the yes is a yes and the no is a no. This one is a bit more interesting. If you look at this, it's the reason that the yeses are yeses is because V2 plus V3 is 17. 12 plus 5 is 17, 3 plus 14 is 17, 11 plus 6 17. The rest, that doesn't add up. And then you say, but you said no one said you could use arithmetic. But of course, people can use arithmetic. Why shouldn't machine learning systems use arithmetic? Here's another one. In this example, you look at the column V4, and 11, 7, and 17 are all prime numbers. So prime numbers are a brand new concept introduced. It's not captured by V1 to V4. So this is cheating as well. You know, how can you possibly expect software to invent prime numbers as a solution to this machine learning problem? But of course you can. And deep learning does lots of invention because it's this gigantic network. Lots of things going on in there. But this is a concept you weren't given in advance, so you wouldn't expect a normal machine learning system to be able to solve that. And the final one is, it's V1 here. 5 is bigger than everything before it, 3 isn't. 8 is bigger than everything before it. 9 is bigger than everything before it, 3 isn't, and 5 isn't. So here you're kind of scanning down the data table. That is the reason the yeses are yes and the no's are no's. And now that, of course, is really weird because you're comparing these rows, which you kind of think of independently, against each other. The point I'm trying to make is that it's incredibly easy to imagine an algorithm scanning down this data table and saying output yes whenever the number in V1 is bigger than anything you've seen before. Really, very 2 or 3 line algorithm. So you can embed very simple algorithms without them being easily found by machine learning systems. And that is my point, that machine learning is really automatic program synthesis and should be seen as such. So the first application I want to look at is embedding into adversarial examples some of these mathematical or programmatic constructs and seeing whether deep learning can extract them. Deep learning is very good. The question is, can it find things like prime numbers? And I would love if someone wants to partner with me on this. And because adversarial examples are all the rage now, add 0.007% of a random noise image to a panda, and machine learning thinks it's now a gibbon. Imagine if that wasn't random noise. Imagine if that was an actual mathematical function generating that with some structure. Then you might be able to learn something about why the neural network is failing. So I think one application of code generation will be to adversarial examples. So association rule mining is very big. You get these kind of facts. Imagine you've got some supermarket data. If you buy napkins and talcum powder, then you also buy whiskey and chocolate. Classic. If you're a new father, as I was a couple of years ago, you can see the sense in that. But this is actually hard, because it's all very clever mathematics for all sign and implication science and for conjunction there. This hides the fact that if you want to test this on a new data set, you've got to apply 3 algorithms. You've got to take your data set and extract all the rows with yes in the nappies and in the tell column. You've got to extract all the rows with yes in the whiskey and the chocolate column. And you've got to check whether the sub-data table from that is actually a subset of the sub-data table from D2. 3 algorithms. So data mining is absolutely automatic program generation. Just so happens that the programs are really boring. Conjunctions, disjunctions, you know, in your wildest dreams. So data mining, I think, can be reimagined as automatic generation of algorithms which are related by a given data set. The algorithms tell you something about your data, but the algorithms, importantly, can be used elsewhere. If you automatically generate code based on the data, then you can take that code, it's actual Java code, you can use it elsewhere. Now, there is a difficulty with this approach, a bit technical, but if you are basically saying that data mining is finding 2 algorithms which are related through data, then it's very easy to generate 2 very different looking programs which actually manipulate the data in the same way. But a neat trick is to pass randomized data through the discovery, and if the randomized data discovery still holds, then the discovery isn't about the data, it's about the programs manipulating data. So my software often tells me that A and B, wow Simon, have you seen that A and B is a subset of B and A? And I say, yeah, really? Because I know the conjunction is symmetric. But that holds for random data, so you can throw it away. So there's a neat trick to get around that problem with data mining now. So I think a big application for me will be to data mining as automated program generation. And I want to look for anybody out there who is an owner of some data about which they want to be told something which they didn't know they were looking for. My software is very good at finding what's called unknown unknowns. So Donald Rumsfeld, now the second most hated Donald in America, he came up with this phrase: there are some things we know we don't. There are some things we know we don't know. They're known unknowns, and some things we don't know we don't know. Unknown unknowns. And my software is very good at finding things that you didn't know you didn't know. So if you're interested in looking at your data in that way, rather than problem solving, classic machine learning, lots of other people are very good at that. Then please do come to me, because I'd really like to work with you on data that you really are invested in. Building on that, we have a position paper in the Computational Creativity conference this year, and we put forward 2 main tenets for this revolution in computational creativity. That the code itself should be celebrated not just as a means to an end to process data to find something out, but as an actual artifact like a painting or a poem. Code is really valuable to people, not just because of what it does, but because of what it looks like and what it means. And automatic program synthesis should be used to problematize the world. So I'm really sick of AI for solving problems. I really want AI to make more problems, make the world more thorny. So we've already seen it with data mining. That's turning unknown unknowns into known unknowns. And if you can write software which generates new video game mechanics, then these are creative affordances. So the problem now becomes, what can you do with this? It's like finding an art object on the beach, or an object on the beach and turning it into an object-to-a piece of art. You get all of these creative affordances with new software being generated. So again, I'm very interested in this idea that software can problematize the world. So yes, HR3, HRs 1 and 2 were used for mathematical discovery, like the theorem about quasi-groups of order 4 over there, still one of my favorite slides. And HR3 has been completely re-engineered, not to be about mathematics, but to be about software, to be about programs. And it can be applied to any data type, and it can be used for data mining, of course, but also for more general code generation. It works by, you start with some existing code, which can either generate data or can read data in from a file, which is roughly the same kind of thing. And then it applies one of these 24 production rules, and there's going to be lots more of these. 10 of those didn't exist a week ago, so I've been implementing them like crazy over the last week. And it applies 24 production rules to produce new methods, i.e. programs, based on the ones that you're given it, and then new ones based on the new ones, and new ones based on the new ones, and it keeps building these things iteratively. Now, it it only concentrates internally on constructing the output which will be produced by the programs, not the programs themselves. That enables it to be incredibly fast. It checks whether two outputs are the same and records that information, and doesn't allow both of those two methods to be built upon, because that would be a waste. And it records whenever an algorithm produces no output, because that's interesting as well. Subset relationships, like you get in data mining, are not recorded until the user does that on demand. Says, here's an algorithm I'm really interested in. What other algorithms have got data in their output related to the data in the output of this algorithm? In classical terms, what it does internally is it writes a piece of code, it compiles it, it runs it, and then it checks the output against all the other outputs it's ever seen. So a lot of effort. And it can do millions of these in minutes. On a train the other night, I got it to generate 1 billion programs in 15 minutes. It's very, very fast, and I'd like to compare it to genetic programming, see how close it gets to that. Code is only ever written out to show the user what the algorithm does, and of course to be a useful object in its own right for usage outside of the system. It's code, it can be run wherever. So I'm going to tell you about an application now, and this is really nearly the end of the talk. If we drop the requirement to make discoveries about data, and we just think about creatively manipulating that data with our new God-given toy of software-making algorithms, then we've got a lot of creative affordances opening up. One application which I really want to get into while I'm here is data visualization. And I'm going to start next week with image filtering. It's an old favorite of mine. You just take the data in there and you manipulate the data into new RGB values. You've got yourself an image filter. But what if we start with no or very minimal data? And this is where I get onto the new piece of art that I've created while I've been here in the last few days, in fact, which I'm calling Style Please. So this is an application to decorative image generation. So I wouldn't call these art. Please don't think I'm saying these are art. These are just pretty decorative pictures. The generated algorithm, and there are 25,000 of them now on my desktop machine, are a bit like evolutionary art or fractals. They take in x, y coordinates and the output RGB values. It's basically how you can generate an image by just scanning through the x and y values, choosing an RGB value according to the program, and turning that into an image. For the generated algorithms to produce these images, it uses things like arithmetic, sine, cosine, and tangent, square roots and powers, and logical conjunction and disjunction, things like that. Then what you can do is you can very easily apply HR3 at the meta level. So what you want are what I've been calling styles. So some of the algorithms can be naturally grouped together because of what the images look like. And so if you apply code-based generation to a meta-level set of algorithms which can look at the images, then you get what I've been calling a style. And the style uses counting to kind of say that there are more black pixels in this one than in this one, and so these two might well be in the same style because of the number of black pixels. And it uses standard deviation to tell you how colourful an image is. Standard deviation is just a normal technique. It's not specific to image generation. And so this one will probably be more colourful than this one, let's say, because there's a larger range of RGB values expressed. So you can get styles out very easily by just going to the meta level. Best if you come and see me if you're interested in this project, and I can go through this with you. But this is all you need to give for this project. A way of taking the numbers 0.1, 0.2, 0.3 up to 0.1 and producing some coordinates based on those, and a way of getting those coordinates back from a string representation. I use strings to represent complex data like coordinates because HR3 only has the ability to work natively with integers, doubles, and strings. So coordinates are represented as strings here. You then have to write some code to apply these production rules. This is basically the kind of things you have to apply to in kind of genetic programming approaches to get interesting looking images out. A little bit of setup, and these are the 4 later on that you need in order to get RGB functions. Again, I can go through that with you. There are some ways to make it faster or limited in the search and have a bit of control over there. But it's really not a lot of effort. If you know what you're doing, this is very easy to do. When you run it and you get lots and lots of outputs, it generated 136,000 methods, of which 117 were different and 19,000 were the same as previous ones. in 35 seconds. So it's roughly 4,000 programs a second, which is quite slow for the software. And here is an example in which this little fella that's as big as it gets, because it's only a 50 by 50 image. Took all of this code to generate. So this is not data mining. You're not expecting to understand the code which generated that image. You really are interested in the image. So there's lots of things going on there, squaring, taking tans and cosines, and so forth. The metacode-based generation, all you have to do is say, from my existing code base of 130,000 image generation programs, get the meta level one, and then call it something, image method in this case. Then you can apply the same production rules. Counting number of algorithms which have a particular output. You've got your standard deviation here. You can do banding, splitting things into 5 categories in this case, and doing some conjunction. And you can have a bit of direction to the search stack. And that produced 5,939 different styles over the 25,000 image generated. And tomorrow I'm going to go to the meta level to get the software to tell me how to order these styles so that you get ones which contrast each other, following each other. Here's a piece of art. This is simultaneously a terrible pun on Style Police and an in-joke for SensiLab, because this is one of the things I've picked up in the 2 weeks I've been here. And it's running outside now on the LED screen. So if you look up close, these are all, really simple artworks, decorative images. Down here is a style. There's no time to explain now, but basically that is looking at the brightness of these things. I know I've written the world's crappiest algorithm to do a photo montage. I could have worked a lot harder on that, and I probably will before I write a paper about this. But that is one style, expressed down here with a little bit of math. This is all generated by the software, I should point out. That's not me by hand. And then here's another. You can see it really is quite a different style. You can really only tell the difference in colours. But this one is looking at the standard deviations, which is basically the range of colours being expressed. So these should be more colourful in general, as well as a different shade or a different colour. And actually, if you look, these are simpler. These are more complex images, I think, than these. So the software also knows the complexity of the algorithm generating these images. So that is Style Police, and it's on the screen outside. I've also written a little bit of code to transition between one style to another. So we've got this kind of benevolent figure of John overlooking the lab. Perfect when you're not around, John, actually, to make sure the style police is being style is being properly policed in SensiLab. Okay, here are 4 things which I can't talk about because there's no time. That's my little girl. It's been lovely seeing her on the big screen outside every day this week, actually. This is a game that I've exhibited as an artistic form, which is very mean. It's got some nasty AI behind it. Please ask me about that. I've also used HR3 to generate new arithmetic puzzles and to solve Countdown. Do you know Countdown, the TV show? The numbers game. HR3 solved all 13 million instances with all the solutions in a kind of 30-minute run. And then I've used it to invent these new puzzles called Donatsis, which is Japanese for donut, kind of a circular version of Countdown, but no time to talk about that. I put this one in for Nina. Every man and his dog has done poetry generation and computational creativity, and I'm no exception. This is a nice paper where the software gives a C poem as a couplet of 2 bits of text, one explaining its motivation, what it used, and one with the actual poem-shaped object in there. I wouldn't call that a poem because I think poems should be reserved for human output, but we did get it read out on the radio. I've also got a nice roadmap for where I'm going particularly, and maybe where the rest of computational creativity should go. But I gave an entire talk on this one slide a week ago, so I won't go into that right now. Do ask me if you're interested in that. And I will stop there, having gone horribly over time, and ask if there's any questions. Thank you. Hi, yeah.
Thanks. Hi. I'm Sharon, and I think that it would be really interesting to look at various areas of AI that are emerging now and think about, basically brainstorm ways that it could be used to either understand or stimulate human creativity. So I mean, one example of each would be, you know, NYT, New York Times now has this whole section on AI, and
Yeah.
one of the things they were talking about last weekend's edition was AI that's being used to write novels. And actually some of it's getting kind of interesting. So you could imagine extending that into a dialogic framework where the platform is a computer, basically a robot, and what the goal is to develop basically a creative conversationalist. I'm sure far from the minds of roboticists who can be kind of pointy-headed. But anyway, and then I was thinking in terms of assessment, there's a lot of work going on right now in basically it's called multimodal behavioral analytics, and the agenda is to understand your partner, or if the robot is assessing the human during this conversational exchange, to understand their social and emotional status, their cognitive status, or their health or mental health status, and so forth. Basically kind of deeply human-centered design. So assessment could certainly be, in this context, could include notions of impact on various dimensions of the human, because after all, when we talk about art, we talk about presenting a really different perspective and kind of, you know, conceptual collisions that cause people to change their perspective on politics or on some topic, or that at least have emotional impact. You know, we develop movies to have emotional impact. So we can start to assess that now. So I'm thinking, you know, it just would be really interesting to look at different pockets of AI and where they are, and whether we could develop ideas that are a kind of bigger picture directions that sort of synthesize things going on in maybe conversational dialogue design and robotics, social and emotionally aware robots, and so forth.
Sure.
To have a lot more impact. And I really think, I mean, not only, I mean, we think it would be interesting, but I'm sure there are a lot of other people who think it would be commercially pretty attractive.
Sure. Well, I can tell you about NanoGenmo, going back to the original idea you mentioned of AI systems writing novels. NanoGenmo generates a novel in 1 month. And it has to be generated, every word, and it has to be chosen by a computer. And it has to be up to 50,000 words. So that really inspires whole different approaches to generating these things, and some wonderful examples coming out there. In terms of changing people's minds through dialogue or physical interaction, one thing I think is going to be on the horizon for, I think, computational creativity is authenticity. Didn't cover it today, but I have this great example of a poem, and it's called Childbirth. And then I tell people it's written by a woman, and you read it in one way. It's a very short poem. And then I tell people it's actually written by a man, and their impression completely changes. And then I say it's actually by a paedophile, and then the impression really changes. And then I say, don't worry, it's actually by a piece of software. And then there is no impression, because people can no longer project any background onto it. It's kind of lost its meaning. And we hypothesize that's because the software has not got any authenticity. It's got no idea what childbirth means. It's just mashed up some words together into a poem. And then I tell people that actually I wrote it, and that is the end of the line. In order to be able to express this idea that software-generated poems really don't have any value in the world until software itself has got some authentic backstory, or the poems are used by a poet. I mean, as a tool, software can write poems all the time. But until the software itself has got a life story, and some software systems do have actual life stories. My software's painted famous people, kind of. And so it does have a life experience which you can draw upon, but we tend not to, no one's used that in computational creativity. The life history of a piece of software to generate authenticity. But I don't think you're going to change anybody's mind. Software can't change people's minds, robotics, in politics or art or aesthetics, until the software itself is talking from an authentic point of view. And I'll stop there, I think. Oh, yeah.
Thank you very much for interesting thoughts. As an art background, so it was really interesting. And first question, like, just what brings to make art using like AI, and also second question could be a bit broad. I think using generative computer system or making art would be very different like depends the person, it depends on the conceptual intention. For example, when I see John's generative art, it's more about like nature of the like law of the nature or bio-inspired that kind of art. And when I use the generative system for cinema, usually making paradoxical sensation, something. So is there any specific or conceptual reason why you use AI for creating art?
Well, I'm not an artist, and I try not to claim that, although lots of people do project onto me, and I'm just using the software as a tool. I mean, I've been in 2 exhibitions with John, in fact, or maybe more. So I've put on lots of arts exhibitions, and some people do confuse me with an artist. I'm more interested in handing over the creative responsibility to the software to come up with a reason for generating images, as well as the generation itself, as well as the kind of post-hoc discussion around those images. So it was all there in a nutshell with the example of the portraiture that I gave, with me with crazy kind of midlife crisis hair going on, and it was trying to express an emotion that it got in a simulated way from a newspaper article or a series of newspaper articles, and so that was its intentionality. Well, that feeds into discussions about intentionality. Did the software intend to portray an emotion there? And then of course that feeds into the art process and the evaluation process. So the software looks at what it's produced and says, have I expressed that emotion very well here? In another example, I may not have this up. Yeah, it'll be here. This was great work from a master's student, Anna, many moons ago. This one here. So this started with the newspaper article, the headline article in The Guardian. It stripped out all of the images and markup and extracted key phrases, and then it used those key phrases to go after Google Images to find pictures, and then he brings back those pictures and paints them up in this kind of artistic way. This was an article on the war in Afghanistan, and this still gets hairs on the back of my neck standing up. The software put together this collage. So this is an article about how bad the war in Afghanistan is by a Guardian writer. It's got an explosion, a bomber plane. Right in the middle is a kind of family with a baby at the heart of this piece. Lots of this juxtaposition was random luck, I should point out. It has a girl in headgear relative to the Afghan geolocation, and then this, and I had to ask Anna what this is because it's quite abstracted. She said that's actually a field of war graves from the south of France, and that was a moment when I thought, wow, this actually does capture in some way a very difficult situation in Afghanistan. So again, the software, we looked at the intentionality going into this, and there were 5 aspects of intentionality. There was the Guardian writer, him or herself, who was intending to show how bad the war in Afghanistan was. There were the software itself. There was me intending to get the software to read the Guardian, which is left-wing, rather than the Sun or the Times, which is right-wing. So I added something there. Then there was the audience seeing this. You know, some people might think it's wonderful to have an explosion and not really see that. So some intentionality coming there. And then we realized there was a 5th entity, which was the people who were tagging images in Google with words like Afghanistan for this. Some people could have had intentionality to show up the worst side of Afghanistan. And so the question of intentionality for this one piece is very difficult to work out, and that's why we've had further experiments with it. So I'm really interested. I mean, I have artistic pretensions. I like putting on shows, but I don't necessarily want to express myself as an artist. I want to get the software to have some element of personhood and for it to express itself through its art. Long answer to a short question.
Last question. I noticed on the picture of the chair that you sold to
Yes, Mr. Young Lam.
Oprah of China, you put your name.
Yeah, that pissed me off. Well, she wouldn't buy it unless I signed it.
Okay.
So this
well,
is
£500.
I know, how
Did you
far
give
is my
the
intention to
£500?
go? It doesn't go past £500. That's basically it. There was cold hard cash to be had. Yeah, she insisted that I signed it because she was projecting me being the artist, and it really perturbed me to do that. But it has gone on. This is her talking at the World Fashion Power. So it's done me a lot of good, and the painting full of a lot of good. But that really upset me. Yeah, I didn't want to do it. She just gave me a marker pen and said, Good spot, that. Yeah, I don't do that. I don't pretend to be the artist. I'm the programmer, basically. I'll call myself a teacher. If I'm teaching it to be artistic, but better than me. That's what we're hoping for, anyway.
All right, I think we've really gone over time, but it was fascinating talk, Simon. Thank you, and Simon's around until November. And he's still sitting out there, so please make the most of this visit while he's here. Thanks everyone for coming.
Cheers.
Yeah.